myself. I'm really hoping this rain pushes up over the mountains and gets me some nice fresh powder for the weekend. But that's not what we're talking about, unfortunately. No, we're talking about high R-value walls and the upcoming 2016 code change and what we see as an advanced energy efficiency building program as what the market needs to do to reach this new code, be ready for it ahead of time, and moving forward. So first and foremost, why are we talking about walls? In the efficiency first mantra, which basically says when you're trying to get down to low energy use buildings, you got to attack the efficiency first. Walls are really the prime example of why that mantra exists and why it's real. First off, you get one opportunity to get it right. You build the walls once, they're not getting upgraded. Very rarely, no one's ripping off the cladding or the stucco and putting in better external rigid insulation. No one's ripping out all the insulation and filling it with spray foam in a retrofit 10 years later. You do this once, it lasts for 50 years, maybe 100 years. This is the envelope that protects that home from the outside environment for the duration of its life. So when you're building, you got an opportunity to do that right the first time, and really the only opportunity when you get down to it. Maybe a few homes will go through upgrades. Second off is that it impacts everything in the home. It's your envelope. It's what dictates the inside temperatures. It dictates comfort. Thermal bridges are huge, as you can see in the photo. All of those heat bands or cool bands, depending on what climate you're in, going into the house, that makes it uncomfortable to be near walls. It makes it uncomfortable to be in certain rooms. It means your HVAC system has to throw heat or cooling all the way out to the extremities really aggressively, or have to have registers out in the extremities. The thermal envelope really defines the thermal comfort of the building, which is a big thing that buyers are looking for. Once homeowners start getting used to sitting in buildings and living in homes that are comfortable in every room and every corner of every room, that's going to be a new standard that everyone's looking for. And there are people building this standard right now. Next two reasons, durability. Once again, you build these walls once, they pretty much stand, and you want to avoid any kind of liabilities, any kind of moisture issues, structural support issues. So building a strong, thoughtful wall, make sure that it's also durable from the weather, from earthquakes, from moisture getting in either from the inside or from the outside. Finally, it is the starting point to reducing every other load in the building. Your walls lower the loads, you can have a smaller HVAC system. You can have shorter duct runs because you can put a good throwing register from the center of the house out instead of running ducts all the way out to the extreme. Once you have shorter duct runs, it's a lot easier to get those ducts into conditioned space, in drop soffits, in plenums, wherever else you can put them in between floors. And then finally, it's a pretty great trade-off for more expensive improvements. Once you get the walls, you can get the walls to a really low U factor or a really high R value fairly cost-effectively, particularly if you throw in QII, and those are some of the more cost-effective improvements, which lets you trade off for other sometimes more expensive performance criteria elsewhere in the home. So let's talk briefly about what's going on in the code world. As you all know, and Shannon just alluded, we just upgraded to the 2013 code in July, and most production builders are now starting to submit permits to this and think about getting into programs to 2013 code. They're still running out permits that had been granted under the 08 code back in June. But the new code, the 2013 code, stipulates across all climate zones a assembly U factor of 0.065. And that's a pretty basic wall. It's your 2x4 with R4 rigid exterior and an R15 high density bat inside. Or if you want to go to 2x6, you can do an R19 plus a R2 rigid exterior and 16 on center. In PG&E territory, this has become pretty darn standard, this R15 plus 4 concept. In some of the southern utilities, the switch over to one-coat stucco and external rigid is a little less adapted, and even some parts of PG&E territory, it's not quite the building standard, but it's getting very close to that. You're going to find as I go through this through this webinar that the expectation or the need to meet the current standard as well as the upcoming standard is really going to require, absolutely necessitate external rigid insulation, continuous external rigid to meet the criteria. The 2016 code change is anticipated to be an assembly U factor of 0.050 in all climate zones except for climate zone 7, since that's San Diego. You PG&E participants don't have to worry about that. And a couple of the ways to reach this is an R19 plus 6 with a 2x6 framing at 16 inches on center, or an R15 plus 8 with a 2x4 and 16 inches on center. As I get deeper into this presentation, you're going to see there are dozens of ways to meet 0.050 or slightly better. These are just two suggestions. And also, because this is a prescriptive change, performance trade-offs will be possible and very common. You might find that the wall that your firm or that you end up building to is a 0.051 or an 0.052. Doesn't quite meet prescriptive, but gets pretty darn close. And that means you'll have to make it up somewhere else in the building. Or you might find the wall that you end up going towards is a 0.45, 0.045 or 0.047, which gets you a little bit of credit, which you can then trade off with other things in the home in the opposite direction. So, speaking of which, here is the U-factor wall table, assembly wall table. So each row is a specific wall insulation R value and framing type. And then the top, you got the 16 inches on center. The bottom, you got the 24-inch on center for the framing distance. And then each column there is a different R value of the external rigid insulation. Now, most common in California and in the world is an R4 with a one-coat stucco. So that third column C is the one that you're most used to looking at. We're going to find that slowly coming out quickly out of product and manufacturers will be more R5 and R6 options, which might help bring down your U factor to that magic 0.050 a little bit easier with a slightly different framing factor, still fitting in your traditional wall construction styles. So first I'm going to point out the two walls that were on the last slide, the R15 plus 8 and the R19 plus 5. Obviously, both of those make 0.050. But as you can see by this chart, there's so many different ways of doing slight alterations, and you might find yourself on ones that are slightly better than that by going to either a wider framing, a thicker framing, obviously, all of these in the 2x6, 16-inch on center, tons of yellow there, things that beat the next code quite easily. Similarly, if you go down to 24 inches on center, you start getting into one option with a very thick external rigid of R8, still sticking to 2x4 framing that beats code. You also have a whole bunch in there that are 2x6 framing and different density cavity bat, the standard density R19 or the higher density R21 or R22. There's also a lot of R23 high-density bat in the market right now, too, which doesn't make this chart, but as you could imagine by extrapolating the data, they just lower the total U factor and make it a little bit easier for you to get there. Also, as I alluded to on the last, when I was speaking earlier, there's going to be a whole bunch of wall assemblies that don't quite get all the way down to 0.050, but get you pretty darn close, and those ones might be a little bit easier to reach early on. You can reach these right now and start getting practice in them, maybe with the expectation to eventually getting to a more aggressive wall and one that beats the next code. But there's some wall assemblies here that are pretty common. If you're really committed to 2x4 and 24 and 16 inches on center, if you put an R6 external rigid, which can be reached with within the typical stucco and window flanges that we have, with a high density external rigid, you can get here with a 2x4 24 on center. You can get pretty darn close to that 0.056. You're not all the way down, but you're close enough that the performance difference will be hopefully easily made up somewhere else in your energy measures.
Great. So Matt, are you ready for this poll?
Yeah, let's do a poll.
Okay. So our first question is going to be, rigid exterior insulation, would you be interested in siding other than one coat stucco? So I'm going to launch that, and I'll let you guys respond. So Matt, I don't think you can see the responses as they're coming in, can you?
I can neither see the poll question nor the responses, nor even the response options. So I'm going to let you direct this one.
I'll read through them after I close it out. It looks like most of you have voted. Okay, so the questions were, or the responses were, no need, all my houses are in stucco. Second option, I didn't think that's possible, but yes, I want more information. Third option, no, it didn't work for me due to cost and other reasons. And then the last option is, yes, I'm already doing that. Matt, do you have a suspicion of what folks responded?
My suspicion is B.
Okay. So actually, it's we got a few responses from A and C, but mostly D. Yes, I'm already doing that, 56%, and then B was 36%. So actually,
Great.
I think I can tell you what this was.
Yeah, if you can put up the poll results, that would be great.
Yeah, do you see it? Everyone, I think everyone can see it.
I think everyone but I can see it.
Okay, well, so the majority was yes, that most folks are doing it, but a lot of people would like to learn more about those other options. So I'll let you carry on, Matt.
So I'm going to go through some common issues and what's going on. And the first one is this one-coat stucco concept. And the reason that I was guessing the answer would be B in the last poll is that I've heard a number of people, obviously not totally representative of this webinar group, that you can only do rigid foam with one-coat stucco, that getting hardy board or wood siding or shingles or other siding options just isn't possible. That's entirely untrue. All sorts of different siding options are possible without too much extra expense other than the standard expense between stucco and wood or stucco and brick and stucco and whatever else. Joe Lisborough, you have to pardon me, I'm in Oakland and it's being loud this afternoon. I'll let that pass before I keep talking. There's a great paper available on Building Science Corps' website. If you search for paper number 1406, and it is also listed later on in this presentation, that goes into deep on attaching various sidings to various siding options to exterior rigid foam board. It also does a great job of question number 2, which is, can I do anything greater? I can't do anything greater than 1-inch exterior rigid foam board. There's a sense out there that 1 inch of rigid exterior is the maximum you can do. And outside of that, above and beyond that, it doesn't fit into the window flanges and the window flashing. It doesn't have nailing patterns. You don't have nails or nail guns that can reach the substrate to make it secure. It's not structurally sound. So similarly to the first one, this is a myth. You can easily do up to 1.5 inches of exterior rigid with no changes to your windows or anything else. And then that same paper I was quoting earlier, the Lisborough paper, shows you some great ways of doing 2 inches, 2.5 inches, 3 inches, and really getting into, in that past chart, some of those higher density rigid exteriors and still doing it at a production scale at similar costs. And the benefit of adding to the rigid exterior is you get no thermal bridges. It's way more effective to add insulation there and add density of insulation there in terms of bringing down your total U factor, because there's no thermal bridging. There's no walls splicing in between your insulation and letting the heat flow through, or the cold flow through those walls.
Matt, we have a few questions right now. Do you want to take those now, or do you want to wait till you finish this traditional wall assembly section?
Let's take them right now. Bring them my way.
Okay. So the first one is a little bit long, so I'm going to read it slowly from Gary Farber. So I'll just read it to you. It is my understanding that R19 is worth, oh, sorry, I don't know what that talking was. Hopefully you can still hear me. Okay,
you cut
so
out briefly after saying R19, so how about you jump back from there?
Okay, great, thank you.
Start from the beginning.
So, it is my understanding that R19 is worth R17.8 in a 5.5-inch cavity, and that R21 is worth R21 in the same cavity. Okay, so that's the first kind of statement. The CEC's R19 U factor is very close to the R21 U factor value. But here's the question. Do you feel that these U factors reflect the actual insulation difference between R19 and R21 in a 5.5-inch cavity?
Yeah, so in the 5.5-inch cavity, the assumption with the three different tiers that chart, that table showed of insulation R factor or R value is the density of the fiberglass itself, the density of the bat. And so if you're putting in a low density bat, a standard density bat of R19, that's going to get you R19. I don't know of a 17.8 bat for a 2x6 for a 5.5-inch framed cavity myself. And then if you get up to the higher density bat, which is the R21, it's a bat that's designed to be at that density. It's not taking a thicker one that's designed to be or at that framing depth. It's not saying put in a bat that's designed for a 6-inch or a 6.5-inch framing depth and shove it in, because you're right, you will lose. If you do that, you would lose U factor and R value. But if you are putting in a bat that is designed for 5.5 inches, that is rated to be R19, you're going to get R19, and the U factors are accurate, in my opinion. If you put one in that's R21, you're going to get R21, and the U factor that is calculated from that is accurate, in my opinion.
Thanks, Matt. And the second question regarding homes that are built on hillsides. So how does this affect hillsides? Oh, sorry, my phone keeps blinking out. Okay, how will this affect hillside homes that have poured in place or 8x8 by 16 block walls on lower floors?
Well, on the hill homes, so I'm assuming you're talking about the exposed side, the walk-in, the lower level walk-in side that's exposed to the outside. Similar, because this is a performance criteria, whatever you build there will be compared against a wall of a .050. Whether you're doing it with concrete or you're doing it with wood framing, doesn't matter. It's going to be compared against that .050. So if you're choosing to build that lower floor with concrete, you're going to need to figure out a wall assembly that adds enough insulation so that the assembly U factor is as close to .050 as possible in order to not get too much of a performance penalty in your compliance calculations. So that can be done by framing on the inside and adding insulation, sort of an external concrete with framed inside that has fiberglass or any other insulation. It can be met by attaching rigid foam board to either the inside or the outside of that concrete wall. It can be met by using insulated concrete forms instead of standard just poured concrete, and that embeds the insulation right there inside the form itself, and there's a slide on that coming up. So there's a few ways to do that, but yes, that walk-in wall is going to get compared to a .050 assembly wall factor. You'll have to figure out a way to get insulation on that. And that's true now as well. I mean, the 2013 code is being compared against a .065 U factor wall. If you're talking about the other side, the subterranean wall, I don't believe that the code is not meant to talk about that wall, and I do not know what the code prescriptive value will be for that subterranean wall at all. I can't speak to that by memory. Shannon?
Thank you. And we had one more question come in, but it's about double walls, and I think you're going to talk about that later. So I'll just let you
Yeah,
carry
let's
on.
hold off on double walls and carry on. So a couple more sort of myth facts that I've come across in talking to builders, talking to Tele24 consultants, talking to framers, etc. The first is that 24 inches on center framing can't be structurally sound. Now you go to 24, especially if you're in a 2x4 world, it's just too wobbly. It won't meet structural code. Building departments won't ever let it through. In fact, 2x4 and 2x6 framing can meet structural code with 24 inches on center. In many parts of the country, 2x6 framing at 24 inches is the standard. Like if you're going to go to 2x6, you go to 24 inches on center no matter what. It's just sort of the norm. And it's what framers typically do when they get to those deeper or wider, I guess, deeper framing members. But also in truth, even if you stick to 2x4, going to 24 inches on center can save you lumber, can meet structural code, and is a great thing to start exploring with and planning with. It might mean a little bit more thoughtful planning on how to line up your windows with existing, with your stud bays, how to line up your roof trusses with the stud bays so that you get the proper structural push of energy out into the walls so that that roof truss actually structurally goes in the right direction. But talk to your structural engineers, and they have all gone to school exactly for this kind of work, and it definitely can be done. The final one is that I've heard a lot of people say that this hasn't been done on a production level. These sort of really high R value, low U factor walls just are done in the custom world only and the passive house world only. Also not true. Canada, Sweden, Oregon, Minnesota, other are already into production homes standard. Most of these you'll see are cold climates, and that's why they went there, is because it's a lot harder to defend. Defending from cold was an earlier step in the advent of thicker, higher R value walls than defending from heat. But here we are in California doing what we do best and sort of leading the charge for cooling dominated climates. And the same thermal world exists. You know, all a thick wall does, all a high R value wall is about is defending the transfer of energy movement across that surface. Doesn't matter if you're defending it from cold or for hot. So as I alluded to earlier, I was at a great conversation at the CEC during the 2016 code conversation, some of the early stakeholder workshops. And there was I'm paraphrasing a conversation of the CEC saying that, you know, we don't see this R6 at 1-inch thick, so we're going to need different windows. We can't, you know, we need to get to R6 rigid exterior, but we don't see it in a rigid foam board that actually fits our existing windows. We only see R4, and there was an insulation manufacturer that says, no, we can do R6 right now that fits behind the windows. And CEC said, why don't you sell it? And the insulation people said, we never knew anyone wanted it. So the conclusion from this is a lot of these insulation companies, some of the big dogs that you're used to working with, Insulfoam, Owens Corning, Dow, and others, are starting to produce and put out into the market R5 per inch, R6 per inch, and definitely when you get out to the 1.25 inch, 1.5 inch, R6, or even R9 in 1.5 inch, which fits behind your standard windows. It might be we're switching up to polyiso. It might be that we're switching out to XPS instead of EPS, but there will be products on the market that can reach this. And as the code when these products start getting used in the market more and more because the code is going up, the prices are going to go down quickly. And some of this R4 per inch board is going to start just going the way of the dodo, the way that incandescent light bulbs are. So another question I've gotten a lot is, what do we see as being, what's California Wall going to look like in 5 years? And I think there's going to be a lot of variability, and this guess might be wrong. So this is just my personal instincts of where it's going to go based on talking to people. It could be some of these little elements shift. It could be that one builder is doing a little better, you know, they're sticking to 16 inches on center, but they're making up for it somewhere else, or they're adding external, but they're sticking with a low density bat, or some kind of trade-off like that. But what I see it being is a 2x6, 24 inches on center, 21 cavity filled, OSB sheathing with house wrap, an R6 exterior rigid 1.5-inch XPS, and any siding you can dream of. This wall that I just described, which to me doesn't seem that crazy, that far out, has an assembly U factor of 0.045, which you can see is better than code, which means you'll be allowed trade-offs somewhere else and still be able to meet code, or you'll be able to build to this and get credit for it in the software that increases your CAHP incentive. It uses very standard construction practices, nothing outside of what framers are used to doing now. It uses standard assembly components, so no new inventing of the wheel. It lowers your lumber costs by going to 24 inches on center, and the assembly costs are actually quite similar once the whole thing to what current common practice is, once everything's learned, and once some of these thicker insulation boards come into market and their prices drop. I also think there might be a play in the production market, especially for some of our smaller and local builders that are really looking to be the cream of the crop, that are looking to be well above their competitors and really put together a great wall. Some alternative wall assemblies, two of which are the double wall and the staggered stud wall. I've talked to a couple builders in Oregon that switched to the double wall and love it. Essentially, their framers are like, I can build a 2x4 frame, just do it twice. Stick them up next to each other, have a gap in between them. That gap distance is variable, and that is filled, as you can see, with a continuous insulation layer. There's no thermal bridging there. So you can do this double wall. You're not having to do an external rigid in this case. You can stick to a standard exterior assembly, no exterior rigid. You still get your thermal break by having that little center chasm between the double walls that is uninterrupted. And you get some really great U factors down to, 0.041 to, into the 0.04s quite easily with a double wall. It does take some planning with that internal wall of exactly how to line them up, and it's a little bit wider, so it takes some framing planning of how to line up your studs and how to build that internal wall, especially right there as the corners meet. But it's doable. It's being done in other production markets. The other wall option that I've seen is the staggered stud wall. And typically this is done by putting down a 2x8 or a 2x10 bottom plate and then staggering your studs so that studs that are only 2x4, so that they don't fill the entire bottom plate. They only fill part way. And then staggering them zipper fashion so that you don't have thermal bridges. So similarly, this wall can be done with 16 inches on center, 24 on center, and it can be done in a way that, once again, no thermal bridges and no need for exterior rigid insulation cladding. These ones I have not seen personally in a production environment, but I've seen some custom homeowners do this, and some framers really love it. It's a great way to build. It's a very functional way to build a high R value wall that gets away from having to do an external rigid if, for whatever personal reasons, you're just against using that type of assembly. So maybe I should field the double wall question now, Shannon.
Yeah, let's launch it. So we have another poll. This is our second poll question, and I will answer it in just a second. So the question is, have you considered staggered walls or double walls for any of your projects? Just a yes or no question, and I will launch it right now. Okay, I'm going to close it. So again, Matt, do you want to guess what the breakdown is?
I'm thinking, well, if I knew which of our respondents were production builders and which were custom, I would say the production builders have not considered it and the custom builders have.
Okay, we can do that assessment later, but I'll give the easy response right now. It's actually pretty close. 42% yes, 58% no. And I guess if we had thought ahead, we could have had a follow-up question to this, which would be, have you implemented either of these, rather than just considered it? But we can do that some other time. So I'll hide this poll, and I'll let you continue, Matt.
Well, and you also said earlier that there was a question submitted through the text chat box on double walls. Maybe I should field that now as well.
Yeah, so let's see. It may be that you responded to it. I'll just ask it again, and you can reiterate. So it's a little bit long from Felix Oyun. So have you looked at double walls? So we just talked about that. But reading through the question, it would look that 12-inch on center. Okay, no, he's just summarizing. Okay, so the question is, does double wall assembly solve the thermal bridging issue without going to exterior rigid?
What an apt question, and yes, as my prior speech went through, it does. So does the staggered stud. So these are definitely alternatives to builders that don't want to deal with a rigid exterior for any given reason, and they are in practice in some parts of the country. And I think if you're interested, talk to your framers. Start figuring out how to make it work. Figuring out is this possible? Is this something that you can go to? I think all of these, the truth is we don't know what is going to become the most either cost-effective or frameable or where the market is going to gravitate towards. But I think double walls definitely have a place in it for some builders and for some homes.
Okay. Well, just really quick, I see a few hands that are up. So if you can, enter your questions through the question bar. We'll take them that way. Thank you.
And we can do hands at the very end if we have time to switch to audio questions. So a couple other alternative wall assemblies that some people might be considering, structurally insulated panels, aka SIPs. And essentially this is a rigid foam board, sometimes between 1 to I've seen up to 24 inches I've seen in some really extreme climates, but any thickness you want, sandwiched between 2 sheets of OSB, and they are put together so you can kind of snap these together and assemble these together as your wall. Obviously, really, really reduces and almost eliminates thermal bridging. You can get some great R factors. One of the biggest challenges with these is shipping distance and shipping costs because they're built in a factory and shipped to site. So unless you are relatively close to the factory, those shipping costs can sort of outdo the gains, and it's better to build your wall on site. But if you are in a location that has a good SIP manufacturer nearby, you might find that these are very cost competitive. And you might find that these are easier to install, faster to install in the field, reduces labor costs once your installers learn how to do it, and it could be a great opportunity. So I would similarly look around and find out if there's anyone building SIPs nearby. And then the fourth alternative wall assembly are insulated concrete forms. I talked about these briefly when I was considering the walkout basement option on a hill build. They're essentially concrete block or styrofoam blocks that have concrete poured into the gaps between them, so you get the structural integrity with the concrete that is poured, but you get the insulation integrity with the built-in foam. Similarly, these get shipped as foam blocks, so they're light, so the shipping isn't all that much, that goes away. But they're an assembly and a construction style that I haven't seen be used in the production market. I might be wrong in some parts of the world, but might be something that you might similarly go find out more about what is available to you, what the pricing is, and if you've got anyone in your territory or anyone you know of that can give you some personal or first-hand experiences in using them. In terms of ability to reach to an R factor and build, I've read a little just anecdotal blog post about a custom home builder that was using these, that switched to these from traditional framing and lumber and loved them. Just the kind of Lego ability of them really made design kind of interesting and easy, gave a lot of flexibility in design. It was something that was really, once they got the hang of it, really easy to construct and gave great R values and U factors. So some additional resources I wanted to point out to. The Building America Solutions Center has amazing selections of CAD files, images, case studies, design guides, all sorts of information for you to get and learn from real people, real experiences in building high R-value walls in a bunch of these different methods, whether it be sort of making a traditional wall assembly a little bit thicker with 2x6 and thicker external rigid, or whether it be switching to some of the alternative wall assemblies like double walls, staggered studs, SIPs, or ICFs. They've got a lot of information in there that's totally for free and can really help you look through and make decisions. The second is the Building Science Corporation's bookstore. These are books at cost, but there's some, $20, $30. I think they might be around that ballpark for some really detailed design guides of building high R-value walls, produced by Building Science Corporation, which is one of the leading authors on in the nation and the world on building better walls, building better envelopes. Some really quality work being done by that team that's worth learning about and perusing. Locally, the Pacific Energy Center has classes and resource library, and some of the stuff that they talk about involve wall assemblies and high R-value walls, so just be on the lookout for that. And then finally, there's a bunch of other free design guides that are not quite as comprehensive as the Building Science Corp ones, but they're free, which is great. One of which I found from Stephen Winter's course called Residential Wall Systems, R30 and Beyond. I found that to be a nice illuminating read. Similarly, there's one from Building Science Corp, but a free one that the measure, this is the 1406, which is incorporating thick layers of external rigid insulation. That's a 140-page design guide with some great information in it. And then there's many more. Excuse me, I copy-pasted this from a prior webinar. That should say many more on Google by searching for high R-value walls or low U-factor walls. My apologies for the typo here. So that is it for the core of my presentation. We've got about 18 minutes left in our hour. So Shannon, are there any more questions in the question panel?
There are. I have 3 questions to start, and you guys can keep rolling them in. So going back to staggered studs, so clarification question. Do you have to install insulation behind staggered studs?
So yes, the idea, and I'll just scroll back to the staggered stud picture there on the right. So the idea here is that you fill that cavity entirely in between. So between the two OSB or sheathing elements, you have complete insulation filled in there, typically a blown-in so you can get into those corners. I've seen so many photos of people, I've seen schematics of people drawing in bat that kind of loops through this as an S-curve and doesn't actually go into the corners. That totally breaks the intent of having no thermal bridging. Having those air gaps kills you. So a blown-in fiberglass or a blown-in cellulose or such would be the best to probably fill this cavity properly. But yes, you got to fill the entire cavity.
Great. Next question regarding hold downs. How do framers install hold downs without lowering the R value on SIPs? Because you have to cut large openings for the hold downs to fit.
So I don't know enough to speak intelligently about the hold down issue. I would have to get back to you on that. I've heard of it, but I didn't do enough pre-research to be able to answer that intelligently. So I'm just going to hold back on and not throw out an assumption. So let's get whoever the name that is, Shannon, could you please write that down, and I'll try and get back to you.
Yep, I've got it. Okay, so next question regarding fire safety. Are there alternative exterior installation products or assemblies that do not have interior environmental quality concerns from flame retardants and other chemicals that off-gas?
Great question. So in terms of off-gassing on the inside, typically the cavity insulation is the one that people are worried about off-gassing. So if you're doing a spray foam internal, there are some people that believe that the off-gassing of that could impact indoor air quality. There are others that believe that's hooey and that it's totally safe if installed correctly. So I'm not going to try and weigh in on that sort of political debate or that, that scientific debate personally at this point. In terms of doing a rigid exterior, I have not heard anyone raise that a rigid exterior panel could have off-gassing issues. Rigid exterior panels, whether they be polyiso, EPS, or XPS, are done in a factory. They sit, they off-gas before they get to the site. As far as I know, I have not seen any papers or any studies that suggest rigid exterior has an off-gassing issue to indoor air quality. If you have one that you are concerned about, I'd be very interested in seeing that so that I can learn more about where that's coming from and if there are counter studies or other information that can be found to help either debunk, dispute, or mitigate the truth. Did we lose you, Shannon?
Sorry, I was on mute. Do you want to talk about the modeling guidelines for the high-performance attics and higher value walls that we're working on?
Yeah, so we are working on modeling guidelines for both high-performance attics and high-performance walls. The walls part was the easiest because we're talking about it right now. Almost every wall assembly I spoke about today is already modelable and should be fairly straightforward modeling procedures that you're used to. We've still developed a guideline that we are going to be distributing. We have available, it's under review and revision right now, that will be available on January 1st for doing some of these traditional assemblies, 2x6 on center, R5 or R6. It's all fairly straightforward. There's also a SIPS option in the model right now. I don't think there's an ICF option right now, and I know that there's not a double wall or a stagger wall option right now. So I've already started talking with the CEC about these. We want to get them into the software, but right now other priorities are above them because we don't have a lot of people needing the double wall assembly option. If you find yourself thinking solidly about wanting to do double walls or staggered studs, please come to me and say so, and we can go to the Energy Commission staff and say, hey, we really need this now because we're starting to build to it. In the interim, as a proxy, we can model a different wall assembly that has the same U factor as the staggered stud or double wall that you're considering. On the high-performance attic world, I don't want to get into too much of the depth, but it's in a similar world. Some of the modeling is available now, and we have modeling guides to do that, and those are available now. And some of the options don't currently have modeling available. That includes the contentious sealed attic, which I know is one that a lot of people are talking about. We are working very actively with both the CEC and program staff and HERS writers and Title 24 consultants and builders to get to a resolution on that. I know that the CEC met last Friday to discuss the sealed attic option, and I have not heard what the result of that meeting was, and I'm hoping to get in on the loop there very soon.
Thanks. And
any more, Shannon?
Yes, we had several more questions come in. First question, can you talk about, I guess, if so, what HERS changes are expected in the 2016 code?
The good news is that there are none. The 2016 code changes to residential code is only proposing 4 changes. One is this high R value wall. One is the high performance attics and or ducts and conditioned space. The third is a lighting measure, and the fourth is a water heating measure, a water heating quality measure, none of which have any direct changes to the HERS rating world. So your world should stay the same. I think what you will find is because the code in general will again become significantly more stringent, that more builders are going to have to call upon HERS tests to use as offsets for other items in the code that they couldn't quite meet. I think QII is going to become very necessary. It's not in the code directly, but in terms of bang for your buck, it's a really big one. So I think quality insulation inspection is going to start coming back into fold quite aggressively as a primary means to have an offset for other measures.
Great. And do you want to talk about metal stud walls?
Metal stud walls. Yeah, so there's a chart similar to that one for metal stud walls that'll give you all of your U factors for different framing sizes, framing depths. obviously the big change here, the big difference here is that metal stud walls conduct, the studs themselves, the thermal bridge, conducts energy, conducts heat way faster than wood does. And so all of these U factors will be higher than what they are here. So the same kind of framing thickness and framing depth will have a higher U factor, probably by about a 0.005 would be my guess by memory. That's totally guessed by memory, so don't quote me on it too bad. But similar, what you're going to have to do to reach the 0.050, that will still be the standard you're being compared to. In order to reach it, or reach close enough to it for trade-offs, you're probably going to be talking about definitely going to 24 on center, probably doing some of the high-density bat, or maybe a spray foam, and definitely doing a thick, rigid exterior.
Great. So next question, how can laths be installed on ridge insulation when using furring nails because they have to penetrate to work?
So I don't know, once again, don't know that well enough to speak to it intelligently. So I'm going to shut my mouth and refer you to the Lisberg paper on Building Science Core, the free one, number 1406, that was in the references, which I believe it talks about that directly. And if not, I think there are other case studies and images of that being done in the Building America Solution Center for free as well. I don't know enough about the detail of that assembly to speak to it.
Okay. And we'll follow up with the slide deck so you can download the link. So Matt, you can help me with the acronym. I know one of them, I don't know the other one on our next question. So does the corrugated SBPO, what's that?
SBPO, it's house wrap.
Okay.
I can't remember exactly what the 4 letters stand for.
Okay. Does the corrugated SBPO or other drainage planks between the OSB and rigid foam insulation break the insulation, potentially bringing in ambient air?
No, because the corrugated channels are the depth that they are, they can be a complement to the rigid exterior. Having that little air gap there doesn't hurt you very much at all in terms of R value. The problem with air getting into assemblies is air flowing through a fiberglass, an air permeable material. That's what the problem with airflow through a wall is. The other potential problem of airflow through a wall is condensation and reaching the dew point if the temperature band of that wall gets to a cold enough point to draw out and the surface inside is not able to handle moisture. But the house wrap is okay in both of those fronts.
And actually, oh, no, I have one more question. It's 12:55, so we have time. Let me just read it really quick. Okay, so I think this is a question closer to verification on these measures. Do you believe that inspectors will look at the energy runs to see what's required, or will the Energy Commission have an enforcement team to audit the building department?
So I know in speaking and hearing Commissioner McAllister speak and a few of the other members of the California Energy Commission is that for 2016 code, the push is to get these into code. And enforcement of code will still have some of the same warts that we're used to, which is maybe not believing that a local building department is really checking this well enough. That's sort of out there in the ethos that there's not a ton of faith that these are being built all the way to spec. That's a darn shame. I definitely wish that builders always built to what they specify in their 1224 documents, and I wish that our building departments always were able to have the wherewithal to inspect and ensure that that's the case. But as we don't want to beat around the bush, but we all know that sometimes that doesn't quite come out. And in 2016 code, I don't see any sort of legal or policy or regulatory changes to change the enforcement mechanism there. I do see that coming into play very aggressively in 2019. 2019 code, I believe from what I've heard, is going to be focused on making sure that these things are actually getting built the way that they're being specified and changing the way that we verify it. And sort of cleaning up the edges around the code to make sure that the homes that get built are really getting built as good as they are designed to and modeled to. Hope I didn't weigh too deeply on the politics there.
This is just an aside, but so in terms of the program, California multifamily new homes also requires a as-built verification. So that includes an insulation inspection, not necessarily QII, but just that they confirm what the insulation values are and that the as-built conditions match what was modeled.
Yeah, homes that go through both the CAHP and the CMFNH programs go through slightly upgraded rigor of verification. And then we also do spot inspections beyond even that.
Great. So Matt, do you have any final words? I think that's our last question for today.
I have final words, which is quality actually matters. All of this that we're talking about so far is, the code language of 24 on sensor, 2x6, R4 rigid. This is a photo of a real wall that I found in the field that is modeled as a 2x6, 16 inches on center, R19 cavity filled wall with QII taken. And as you can see, and their Title 24 run gives them credit for all that insulation. As you can see quite clearly, this is a solid wood wall which conducts heat horribly straight through it. Kind of alluding to the last question that I answered, quality in the field really matters. And professionalism and sort of making sure that you are considering the impact, the actual building science impact, not just sort of the Title 24 switch you can do in Energy Pro to get credit. Not just considering the concept, but considering the installation of it and making sure that these walls are really, because the real root reason of building the walls to this quality and building the walls to this standard is that you're selling a more durable, longer lasting wall with less cold spots, that has good thermal comfort, that reduces HVAC callbacks, that makes your home buyers happy. And that takes a quality sense all the way through, not just a checkbox in Energy Pro. So thank you to all the builders, the Title 24 consultants and HERS raters who are out there really making sure that we're not just modeling walls, we're building walls that really stop heat flow well and make the occupants of those homes happier and more comfortable. So that is it for us. I am Matt Christie. I run the CAHP program for PG&E. The team with CAHP is me, Kevin Robinson, Michelle Waffle-Otero, and Deborah Heyman. And the CMFNH group, California Multifamily New Homes, is Sophia Hartkopf, Scott Kessler, and Shannon Todd, who was helping me host today. So thank you very much to everyone online. We are at 1 o'clock. So without any further ado, Shannon, unless there's something else that has cropped up, thanks for joining us and have a great afternoon.
Yeah, let's wrap up, and we'll send all the slide information and the recording. Thanks, everyone.
Bye-bye.